Today on the bench I have a Hewlett Packard 410B vacuum tube voltmeter, or VTVM for short. This I just recently picked up at a local auction, and from the photo that was supplied, because it's an online auction, I could see that the probes here, like this common one, has no probe tip in it at all. This has the collet nut missing from this particular probe, and so I thought, yeah, well, I'm probably going to have to make or find a suitable replacement, because I want to try and keep the probes original if I can. And we start to go through this. Before we even get to a point of powering it on, just want to check that all the controls actually function. So just going through this, switch feels okay, this switch feels okay. You can see how dusty and dirty and grimy this is. Pots seem to rotate okay, and we get to the ohms adjust, and this is absolutely it was frozen. I've just managed to free it, so it might need a little bit of lubrication there. So okay, so there's a little bit of work to do there. Now let's go and have a look at the rear of the equipment and see what we find out about that. Okay, so for those of you not familiar with this piece of equipment, the rear panel comes off, and the way it does this is there's a button up here, and this pull ring here, you can put a finger in to actually give it a pull. So you hold and pull, and you can then remove the panel, and we've got something inside here. So before we get to that, it actually gives you the positions of the valves or tubes in the unit. This is the ballast for the heater circuitry, so maintain constant heater voltages. And in here we've got a couple of containers. We've got a few things in them, so let's just get them out and have a look. It says on here, jig for making meter probes. Well, that's interesting. And testing probes. So, that looks good too. Alright, let's just open this up and pour these out. I'll just move the meter back a little bit so we can get an idea of what's going on here. And oh, look at that. Wow. So I'll just move the camera so you can see a bit better, and we'll zoom in a bit, and we've got a whole series of probe tips. So the missing ones I had, and missing parts, we've got enough to cover that. We've got a couple of banana 4mm banana connectors. We've got a couple of fixed probes as opposed to the collet type, which you can replace the probes. We've got a couple of slotted type spade terminals, so you can actually screw them down to something, and a couple of alligator clips, and they all screw into the probes. So that's excellent. And then in this one here, they've got marked as a jig. Let me get that there. I'll just make this move a bit so you can see, and I'll open this up. Oh, I've just dropped a nut, but this looks like the same thread, and looks like some sort of jig. I'm not quite sure how to use it as a jig, but for making up these threaded brass sections that screw into the probes. So that's excellent. That means I don't have to worry about trying to reproduce something for the missing pieces on the probes. So that's excellent. So that's a good step forward. So what we'll do now is just pull the unit out of the enclosure. Before we do that though, I'll just put this onto its side and spin this around so that you can see. And we've got this connector here which has all the probes on it. We shall just disconnect this from the thing. I just hope I'm not getting in the way of the camera here. I'll just unscrew this and that, and you just loosen this off, and this whole section plugs into the base of the meter. It's just a matter of carefully unscrewing it. It's still connected, but we're nearly out. Okay, so that's out, and that one's out. So that just falls away and unplugs. So that means we can get our meter probes out of the way. Then we right this back up again so that we can get to with a Phillips screwdriver and just undo these screws here, which feels like there's actually going to drop off the back, so it seems like there might be something a bit loose there. And we'll do this one. And the end is actually moving forward as we speak. We're nearly there. Okay, that screws out. Now the whole front face should pop out, and we can move the this way. So I'll just give ourselves a bit more lead length. But unfortunately, the power cable won't go through the hole here. It's an Australian mains cable, so the hole isn't big enough for it to pop through like it would a US mains cable. So we'll just get that so that we've got things better organised, and we can now see, we can see the back end here. You can see it's quite dusty and dirty, but it's not. There might be a little bit of surface corrosion, but nothing really major, so that's quite good. And we look around here, you can see that the component, actually some of the componentry looks like it might have been replaced. We've got resistors here and here that don't look original, and we'll go over this side, and again we've got, if you can see here, these aren't original resistors used in this, and in fact this is tacked onto this one here, so we're going to have a little bit of a look there. Also, in the most of the units, well, as far as I know, have a selenium rectifier here, and this has already had a silicon rectifier to replace that selenium. So there's obviously someone's been in here in the past, and in fact the line cord that's on here is moderately recent because it's using brown and blue for active and neutral lead wires and a green with yellow stripe for ground, whereas if it was the original US cable, it would have been black for active, white for neutral, and green for protective ground. And if it had been done possibly more than 30 or 40 years ago here in Australia, that would have been red for active, black for neutral, and just green for the protective ground. So it's been probably, I would say, done in the last 30 years, this cable. But yes, there've been a few mods done to this unit, so we'll have to actually have a look as to why they've been done. Now, also, it looks like it's relatively recently. In here, it's only an 85 degree C, a 10 microfarad 250 volt electrolytic has been placed in, and a tag strip has been placed on the bolt holes of the original electrolytic capacitor that would have been sitting here. So we've had the electrolytic replaced already, but I think we'll replace that anyway because we just don't know its provenance, but we can test it in any case. So there's a little bit to check out, a bit of cleaning to do, but hopefully there should not be too much wrong with this unit. Alright, that's the initial appraisal pretty much done. After a bit of effort, the controls and the meter have come up quite well, just cleaning everything up, getting rid of some of the dirt and grime. I've tested the tubes and they're fine. I've checked out all of the resistor values, particularly the replaced resistor values, and they're all within spec. The only thing was that the zero adjustment range had obviously been slightly increased with an extra resistor in parallel with a 6K8 resistor that's in that part of the circuit to bring it down to about 5K4, so it'll give a slightly bigger adjustment range on the zero, but that doesn't seem to really be an issue here. I went then next to start verifying the calibration of the DC. You first have to set the DC gain of the system up before any of the other modes like AC or ohms can be calibrated with any degree of confidence. When checking the calibration of this meter for the DC ranges, I found that it would set up okay at full scale and read pretty well spot on back to certainly about 60% of full scale, but down below in the region, say 20 to 40%, but really extending from probably about 10% to 50%, the error was starting to increase, and that's to be expected, but it was actually outside the specification given in the HP manual. So I thought, okay, what have we got going on here? Is there an issue with the meter movement? And after repeated tests that I performed, I was starting to find that occasionally the meter needle, particularly when you didn't have a lot of momentum, say going from full zero to full scale, but only going up the scale to say 20, 30, 40% or so, the meter would tend to look like it was sticking before it actually got to the setting that you had intended, and you could actually tap on the meter and it would then move a little bit, and similarly coming back to zero it was tending to stick, but it wasn't always in the same place. It was quite variable. So I initially was thinking possibly a bit of swarf or something in the meter movement, a little fragment of ferrous metal or something that might have been sticking, but because of the intermittent nature, I thought, no, it's got to be something less aggressive than that. So I then proceeded to take the meter apart, and I'll recreate this because I didn't have this on camera at the time. The 4 screws in the corners of the meter here are what holds the whole meter into the panel, and you can just remove those and the meter will come away. We'll just get these out. And lift the meter away, and you'll see there's a capacitor across the meter here, and just with some adjustable spanner, just loosen off the nuts on the terminals of the meter, take them off, and we have the meter movement out. Okay, with the meter out, the next step is to undo 3 screws that hold the back of the meter into the face. These have a spring washer underneath. Just got to be careful you don't lose that, but you can just draw the whole meter movement out like so, and if we just carefully drop these out, that's all the screws dropped out. I'll just make sure that they're all put to one side out of the way, and there's a gasket around here as well. This one's actually a little bit deformed, so it probably doesn't do the best job. But now what we have is the actual meter movement, and we'll just zoom in a little bit, get that to focus. And it was fairly difficult for me to actually see down here because I had a fair bit of strong light trying to look down along the meter magnet, the curved section of the magnet where the coil goes around. Now I'll just carefully do this, you can see in there the coil as it moves, and what I suspected was that, and I could actually see a small amount of corrosion in the area, and little spots of corrosion. Those I thought maybe were just intermittently fouling on the meter coil as it moved, and particularly with a low momentum coming up here, that it was causing it to stick. So I thought that maybe what we should do is just use something like Deoxit to try and remove that. Unfortunately, the nature of this is you can't really get anything down in there without damaging the movement, so you can't aggressively scrub the surface like you can on a pot or whatever. But I thought just flushing it. So the first thing I used was Deoxit D5, did 1 spray of that, and that didn't really do very much at all. And I was also concerned that there might be some residue left that might also cause issues. With that, as I said, it didn't seem to make much difference. So next I tried some Fader-Lube, some Deoxit F5, and that actually cleared up most of the issue. We weren't getting any sticking with the movement in this 20 to 40% of full scale range. But what happened then was, when it was returning to 0, it got rather intermittent as to coming back to the 0 point. And what I suspected then was the fact that rather than it be surface corrosion that the actual coil was fouling on, that it might actually be dirt and grime that had got into the jewel bearing that's in these. Well, certainly, I don't know if these have actually got a jewel bearing, I presume they have, but certainly into the bearing for the meter movement. So the next step was to take off the meter scale so that it wouldn't suffer any damage potentially from isopropyl alcohol. And the idea then was to upend this, so lift this up, I'll just move this out. So we had this vertical in my ultrasonic bath filled up to about here, so that it covered the whole meter movement section, and ran the ultrasonic bath with isopropyl alcohol for about 10 minutes. After that time, the movement had freed up enormously and was coming back to zero. So I then shook off a lot of the excess isopropyl alcohol and then placed this in toaster oven for about half an hour at 60 degrees C, just to bake out any of the remaining fluid. And that seems to have actually resulted in the meter functioning correctly. So quite possibly it was more likely the bearings in the meter had accumulated some dust and dirt over the years, and the spraying of Deoxit D5, I think, actually moved the position of that dirt and grime closer to the 0 point and got rid of it in the areas where the meter was actually sticking at the 20 to 40% range. So that's now fixed, and I was able then to actually do a proper DC calibration, and I'll talk more about that in a moment. After letting the HP 14B warm up for about 15 minutes or so that it can thermally stabilise, you should be able to adjust the zero setting to give zero on the display, and then actually be able to switch between positive DC and negative DC without any significant change to the meter needle. And that's what we've got here. Next, we should be able to go and check the calibration, and for that I'll just show you, we're just using a Keithley 230 programmable voltage source, and while the Keithley is not up to the sort of level, or this particular unit anyway, is not up to the level of a Fluke calibrator with say 7 or 8 digit precision, it's way better than I need to actually calibrate the HP 14B, at least on DC volts. Now with the Keithley 230 supplying 1 volt into the HP 14B, you can see that it's slightly off of 1 volt, so we'll just get around the back here and adjust until we get close on 1 volt, and you can see that that's pretty right now. Now if I go to 0 again, we've got 0 showing. Okay, now what we'll do is try some part of the way up the range. So let's go for 200 millivolts, and it's just a hair over 400 millivolts. It's just slightly high again. 600 millivolts. Again slightly high. 800 millivolts. So we could actually slightly reduce our gain to try and improve over the whole range. So now if I go back to 200, it's still a fraction higher there. If I go to 1 volt, that's reading just a hair under, not even that, but it's close. So we go say 100 millivolts, and that's where most of our error is, and we're talking, it's reading 110 instead of 100. And if you do the quick math on that, that is 1% at that point. It's 1% high. So that's quite good. Now if we go, say, to a different range, let's say, set this to 0 to start with. We'll change ranges. Let's go to 3 volts, and we'll put 3 volts in here, and it's reading 3 volts on the scale below. If I go to just a minute, we'll go back to 0. Just redo that. So if we say 2 volts, it's reading just a hair high, and 1 volt, and we're reading certainly better than 1% at that. So now if we go to, say, our 10 volt range, and it appears that down at 10% of the range we are about 1% in error, which that's 1% of full scale deflection, I might add, and Hewlett Packard give a specification of plus and minus 3% of full scale deflection, so it's quite a bit better than the absolute worst spec that they offer. So now if we go to 10 volts, and that's reading pretty well spot on. It's just a hair high, but that's okay. And then if we go to 30 volts range, we're reading just a little bit high. So generally it's reading slightly high, but that's fine. So now we go to 30 volts, and considering the technology here, it's not doing too bad a job, because most analog meters, I'd never say they're much better than about 2%. So that's that. So we go to 100 volts, and that's reading just slightly low on the 100 volt range. So we go to 100 volts, and again it is just slightly above, but that is fine. That is more than adequate for a meter of this caliber. So that's the DC range done. I mean, we could go higher. I can go up to 300 volts, and we see the 100 volts on that range is reading quite well, and the Keithley doesn't have capability to go beyond plus or minus 100 volts, but that's fine. After further checks of the AC ranges and the ohms ranges, this HP 410B has just come up and it's within spec and seems to be quite stable, so I'm quite happy with it. And just to conclude, I'll put up a still shot of the sorry looking condition it was in at the auction where I found it